The final functional group that we are going to look at, the final special organic compound, is a very special one indeed. It appears all over the place. It's been studied throughout history. It has many different naming conventions that go right along with it. This might look like just your ordinary cyclohexene, but it has a very special structure. The reason for that special structure is these three double bonds are spaced evenly apart. What that does is it causes resonance. Let's look at a little ball and stick model to help us understand. I've got this drawn just like this. Okay? So I've got these double bonds here. But if I were to look at this molecule from a side view, so head on like this, well then I would notice where these springs are coming up, this is where my pi bonds would form. I'd have sigma bonds between each of these molecules, but my pi bonds would form above each of these double bonds, above each of these springs. Well, if I've got pi bonds hanging out right there, hanging out right in this area here, and right in this area, well, then there's this empty space around it. You just have to imagine this. There's this empty space where there is no bond. Well, that electron is going to want to move to the empty space because it's less negative. And so these electrons, these pi bonds, are actually going to move back and forth between the carbons that are next to them. And that's going to create resonance. So really, I could draw a resonance structure here. And have this having double bonds like this. Both are accurate. And in reality, both are true. And so when I have a molecule like this, it gets these special properties. Because suddenly, because this is resonating, these bonds don't really qualify as double bonds or single bonds. They really qualify more as 1.5 bonds. And when these come together, I'm going to draw them with just a circle in the middle. This compound, this specialized compound, is called benzene. It has a place in many different molecules. It's responsible for the sweet smell in gasoline. It is very volatile and very flammable. It is the basis for several neurotransmitters, including dopamine and serotonin. It's responsible for many of the aromas that we find pleasing, like the smell of cinnamon, cinnamaldehyde. The base of that compound is benzene. And so we're going to look at how to name benzene. As far as carbon chains go, it's going to take the same priority as any other alkene would. I've got 3 benzene structures drawn here. The first one, just a benzene. I see the benzene ring. That's going to be my base name. Nice and simple. And then I've got a 1, 2, 3, 4 carbon side chain that is branched on the number 2. So this will be 1, 2, 3, 4. So this will be a butyl group. I'm going to have this coming off of the 1 carbon. It's the only functional group, so that's going to be number 1. So this will be but, and then, since it's attached at the 2, but-2-il-benzene. Nice and simple, very straightforward, just like everything we've done before. It doesn't get a specialized naming convention. It's just benzene. Now here, again, my only functional group, so that's going to be the number 1 carbon. This is an ether, and so I'm going to have this being 1, 2, that is F-oxybenzene. Okay, great. Last one. Notice, I've got the double bonds drawn in here. Anytime you see this, you should assume this is benzene. Benzene can be drawn like this or like this. It doesn't make a difference. So I've got a 1-ethyl, 2-methyl. Okay, 1, 2, and 1. So this is going to be a 1-ethyl, 2-methyl benzene. Fantastic. Now there are some specialized versions of benzene. that will get special names. These will have very specific functional groups hanging off of it, and we're going to look at 3 of them. There are more, but they are steadily being eliminated systematically, but these 3 are extremely common, they still exist, and you will need to be able to use them to name things. The first special compound will be a benzene attached directly to an alcohol. Notice, this is an alcohol attached straight to the benzene. It would not count if it was an alcohol hanging out like this. That would not qualify as this special case. This special case is only that alcohol directly attached to the benzene. The special name that this gets is phenol. So when we see a compound like this, when you see a benzene ring attached directly to an alcohol, that will be named phenol. And any other functional group attached to it will be named according to that functional group, with this phenol as the base compound. So if I threw an ethyl group on here, well then this would be 1, 2, 3. This would be 3 ethyl phenol. 3 ethyl phenol. Okay? It doesn't get changed to hydroxy or benzene-all. It is phenol. Great. Next one. This will be a benzene attached to an aldehyde. Now, benzene and aldehyde, normally, because benzene is just a cyclohexene ring, it gets the same priority as a cyclohexene would. So it's not going to get a special priority. Normally the aldehyde would have a higher priority. Normally this would be a methanal with a benzene side chain. But in this special case, and only in the case where the aldehyde is directly attached to the benzene, this will get a special name of benzaldehyde. Aldehyde. There we go. It's not going to be benzenal. It's going to be benzaldehyde. Okay? Even if I toss another functional group on there. Now, the priority of functional groups also applies to these names. An aldehyde takes precedence over an alcohol. So if I now attached an alcohol here, this would be 1, 2, 3. This would be 3-hydroxy benzaldehyde. The naming, the functional group priority still takes precedence. And lastly, we have a carboxylic acid attached to a benzene. Now again, benzene doesn't get a special naming priority. It's just another carbon chain. There's nothing special just because it resonates or because it's round. It doesn't matter. This isn't going to be, this would normally, carboxylic acid would normally get a higher priority. Normally, this would be a methanoic acid with a benzene side chain. But instead of doing that, we give this a special name because it is so common. The special name is benzoic acid. And again, the normal functional priority applies. So if I then attached an aldehyde here, this would become benzaldehyde-oic acid. This would still be benzoic acid with a 3-formyl. 3-formyl benzoic acid. Okay? There's one more thing we need to look at, because benzene can also function as a side chain. Okay, so when is benzene going to be a side chain? Well, it's really going to become a side chain in any case where it gets beat out just on the pure carbon chain length. So what would this be? Would this be a 7-long carbon chain on a benzene? Or would this be a benzene on a 7-long carbon chain? Well, 7 beats 6. There's only 6 carbons on the benzene ring, and there are 1, 2, 3, 4, 5, 6, 7 carbons on this chain. So this is a heptane. And that benzene is hanging out on carbon number 4. It's going to be number 4 either way that we name this, either way that we number this. But we do give it a special name when it is a functional group, unfortunately. It is going to be named 4-phenol. Okay? Whenever benzene is a functional group, it gets the name phenol. So this gets named 4-phenyl heptane.